All right, Unit 9, Day 1. This unit, we're going to start looking at two-dimensional shapes, looking at interior sum of their angles, things like that. And then, the big thing we're going to be looking at this unit is area of two-dimensional shapes. But this first section is all about angles within those two-dimensional shapes. And the big idea to come from this one is what we'll see in this example here. Okay, so here I got a 3-sided, 4-sided, 5-sided, 6-sided polygon. Okay, in each one of these, we're going to draw diagonals from one vertex and notice how many triangles that are formed. So if we look at a triangle, 3 sides, you can't draw a diagonal. Okay, we have a segment that's drawn from one vertex to each, and those are my sides of the triangle. Okay, one triangle is formed. Now if I go to a quadrilateral, let's say we go to this vertex and I draw a diagonal. Okay, we have 2 triangles formed. Now we know the interior sum of a triangle is 180 degrees. We know that the interior sum of a quadrilateral is 360 degrees. Okay, if I go to a pentagon and I do the same idea, go from one vertex, draw diagonals, I can form 3 triangles. So if you can guess, 3 triangles, one triangle is 180, 2 triangles, double that, that's 360, 3 triangles, 540 degrees. Do that with a hexagon now. I can form 4 triangles. Okay, hopefully you see the pattern here. Okay, each triangle that I add to a polygon, another 180 degrees. Okay, so that's what brings up our formula. Okay, this is the formula that allows us to find the interior sum of any polygon. Okay, n is the number of sides. Okay, so n minus 2 times 180. Hopefully you noticed. Okay, up here, 3 sides forms 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. It's always 2 less triangles than the number of sides. Okay, so that's why we do the n minus 2 and then multiply it by 180 because 180, that's the interior sum of a triangle. So again, number of triangles, that's what my n minus 2 is. Now, when we get a little further along, we can figure out each individual or each interior angle, and that's going to be for a regular one. That's going to be our formula. So we'll put that on the back burner for right now, but we'll come back to it. So I kind of just filled this one out. Triangle, quadrilateral, you know those two. Pentagon, hexagon, we even drew those. Okay, so we had 3 sides, we formed 1 triangle. We had 4 sides, we had 2 triangles. 5 sides, 3, 6, 4. Okay, so again, in this situation where we just have n sides, which can be any number, we have n minus 2, the triangles, and we multiply it by 180. Now, with this unit, we're going to have to memorize some sides and how we classify polygons based on those sides. And a lot of these you've seen already. You probably know most of them. Okay, 1, 2 sides. We can't create a polygon with those number of sides. To create a closed shape, we need to have at least 3. So 3, triangle. 4, quadrilateral. Okay, 5, pentagon. Okay, most important defense building in the United States, pentagon. Hexagon is 6. 7 is heptagon. 8 is octagon. 9, nonagon. And 10 is decagon. Okay. Simple as this. You have to memorize those. Okay. Biggest issue I've seen teaching this class for the last 2 years is people do not memorize the names. Okay. Memorize your names. You're going to be sitting a lot better. All right, so sum of angle measures. Find the sum of measures of the interior angles of the convex polygon. So we got a tengon. That's 10 sides. So again, our formula to figure out the interior sum, n minus 2 times 180. So if I go a 10 gon, 10 minus 2 times 180, which will give me 8 times 180. If I go over the 12 gon, 12 minus 2 times 180, that's going to be 10 times 180, which gives me 8 times 180, I get 1440. So that would be the interior sum of a 10 gon, which we call a decagon. Okay, 12 gon, 12 sides, that's going to be 1800. And I know I didn't have a name for that, but that's what we call a dodecagon. Okay, now, next ones, heptagon, octagon, 13 gon, there's the answers. Okay, so pause the video for just a brief minute or two, try to get those answers. And if not, that is where we need to be asking questions when I return. Okay, so now that we know how to find the interior sum of polygons, okay, we can look at questions like this where I find x. Okay, the big thing here is I need to find what the interior sum of this would be. So I'm going to count my sides. I got 6 sides. Okay, so if I got 6 sides, it's a 6 gon, or what we call a hexagon. It's not a regular hexagon. It's still a hexagon just based on 6 sides. So again, to find the interior sum, 6 minus 2 times 180, 4 times that 180, which will give us 720. Okay, and again, that is my interior sum. That is saying that all these angles should add up to be that 720. Okay, now, that's what I'm going to do to set up my equation then. I'm going to add them all up, set it equal to 720. So x plus 136 plus 136 plus 88 plus 142 plus 105, that is equal to 720. Those all add up to be 607. Subtracting that over, x is 113. Okay. Now, make sure, do not forget any of those angles. Work your way around, add them all up. Okay. Now, for this next one, I want you guys to pause the video for a minute, give it a try, and make sure to get 217. Okay. Now that you've gotten 217, or if you didn't get 217, there is the work that you should have done to get the 217. Okay, now this is where I had mentioned earlier. Okay, find the measure of each interior angle of a regular polygon, because again, remember, to be a regular polygon, this is way back. I'm actually not sure if we covered it, but a regular polygon is where all the angles and all the sides are congruent. Okay, so this is where I'm going to use n minus 2 times 180, which is my interior sum, and we divide it by the number of sides. Okay, so in the first situation, 12 gon, we actually found the n minus 2 times 180 part. Okay, but we'll do it again. But now in this case, I'm going to divide by 12. Okay, like on top, we get 10 times 180, which gives us that 1800. Now, 1800 is the interior sum. Okay, so all those angles need to add up to be 1800. And if there's 12 sides, that means that there's going to be 12 angles within that polygon. And if they're all congruent, that is why we divide by 12. Okay, so in this situation, that's going to give us 150 degrees for each of them. Okay, now go ahead, try it for the heptagon. In this situation, you should get 128.5 0.57 degrees. If you do not get that and you still can't get it when I get back, make sure to ask that for the next class period. Okay, now the measure of each interior angle of a regular polygon is 140. How many sides does a polygon have? So this is kind of switching it up a little bit. Okay, if you think about it, okay, here it gave us the angle measure, right? But now when I look at this one, it's actually giving us the angle, okay? So I'm still using that n minus 2 times 180 over n, okay? Again, that was the formula to find the measure of each angle in a regular polygon. Now I know it. Oh. Now I know that it's 140. And I need to figure out how many sides there are. Because again, n is what's representing the number of sides. So it's a matter of you have to memorize this formula and know when to use it. Understand that that is representing the measure of a single angle in a regular polygon. Okay? And if I'm given that angle, I set it equal to that. Now, to solve this, we're going to multiply both sides by n. That way I can get rid of the n in the denominator there. We're left with n minus 2 times 180 equals 140n. Distributing there, 180n minus 360 equals the 140n. Subtracting that over, adding the 360 over, end up with 40n equals 360. Divide, n is equal to 9. Okay, so a regular polygon that has 140 degree angle measures, that's what we're talking about, a nonagon, 9 sides. All right, so go ahead, pause the video, try the next one. You should get n equals 30. If not, there's the work that follows. Okay, now one thing I do want to mention, okay, I'm asking you to pause it because that is what's going to allow you guys to actually learn this stuff. If you don't do that, don't expect too much of yourself. Okay, so make sure you are pausing the video and doing the practice. All right, now we do need to also talk about exterior angles of polygons. Nice thing with exterior angles, no matter how many sides there are, the exterior angles always add up to 360. Okay, now again, my exterior angles are like if I extended the sides and it's the angle formed with that next side, that consecutive side of the polygon. Okay, and just like just like any other, like an interior angle, if there's 5 sides, there's 5 interior angles. If there's 5 sides, there's 5 exterior angles. Okay, now again, all those angles are going to add up to 360. Okay, and that every single time. Now, if I want to find the exterior angle of a regular polygon, okay, and again, just like with the interior angles are congruent. The exterior angles of a regular polygon are congruent as well. So I'm just going to divide by the number of sides. Now, don't always have regular polygons. Okay, so like here, we do have 1, 2, 3, 4, 5 sides. We do have a pentagon here. Okay, not a regular pentagon, but again, I got 5 exterior angles. Those 5 angles should add up to 360. Okay, so 4x plus 2x plus 2x plus x plus 3x. That's going to add up to 8, 4, 8, 9, 12x. Divide by that 12. We're going to get x is equal to 30. Okay, now when I go over here, noticing that all the sides are congruent, all the angles are congruent, tells me it's a regular polygon. Okay, and there's 1, 2, 3, 4, 5, 6, 7. Oh, wait, 1, 2, 3, 4, 7. 7 sides, 7 angles, 7 exterior angles. Okay, and they're all x. Okay, So I got 7x. And again, those angles add up to 360. Okay, so divide by 7. We're going to get x equals 51.4 degrees. All right, so again, pause the video. Try this next one. Get 78. Okay, if you don't get 78, here is the work that goes along with it to get to 78. Okay. So yet again, if you are not getting these when you are practicing them on your own, these are the types of questions I expect when I get back. Okay, so that is our interior sums. Okay, finding individual angles of polygons and exterior angles. And again, make sure you memorize the names of the different polygons by the number of sides. Okay, 9-2A, again, okay, that's just some extra practice if you want to give those a go. This one, we're going to talk about area of triangles, rectangles, and parallelograms. Now, at this point, you guys should know how to find the area of triangles and rectangles. So just a little bit of a quick review. Okay, formula for a rectangle, base times height. Okay, where triangles is half times base times height, or you can think of it as base times height divided by 2. Either way. Okay, and we'll do one example of each. Well, maybe a couple of them, but I'm going to roll through them quick. Okay, so here we got a square, which is a type of rectangle. Remember, a square is more specific. Base times height. Okay, and I want us to get in the habit of writing the formula. Okay, we need to know base, we need to know height. Base is 6, height is 6, so area is equal to 6 times 6, or 36. The other thing we need to get good at this unit is units. Okay, feet times feet gives me square feet. So my area of that square is 36 square feet. Now in the triangle, again, we got to be able to identify the shapes. I like to think of it as base times height divided by 2. We got to figure out my base. We got to figure out my height. Now with triangles, you can define your base how you want to. Okay, your height is going to be the perpendicular distance coming off of that base, though. So like in this situation, I'm given that altitude. So that's the height where this 7 would be the base. Okay. Like if I was to use this 4, okay, I would have to find the altitude or the perpendicular distance from there, okay, which I do not have. So that is not what I can use. In this unit, there's going to be a lot of times where we give you random things that aren't actually used. So like in this situation, that 4 is not used. So be careful. So area, 7 times that 2.8 divided by 2. 7 times 2.8 divided by 2, 9.8. In this case, square kilometers. Okay, now we just got done with the trig unit. We are going to have to use trig. Okay, because like in this situation, we are going to use one side. Like if I use this, let's use this 3 as our base. Okay, I'm going to need the perpendicular distance to that. And I do that, I get that from the altitude. Okay, this is my height if I was to use that 3 as the base. Okay, if I'm going to use the 6 for my height, I gotta find that for my height. Okay, so it depends on, you get to choose what you want to use as your base. Okay, but your height is the perpendicular distance. Okay, now I like to use the green that I have there. And again, base times height divided by 2. Okay, where my base is 3, my height, I do not know. I have to solve for that height. Okay, now, if you notice, got a linear pair there, so that's 40 degrees. And I know that this hypotenuse is 6. Right here is the 6. Okay, I have 2 known things, so I can find height. Okay, opposite, and then that would be my hypotenuse. Okay, opposite hypotenuse, so that's our sine. So sine of 40 degrees is equal to the opposite, which is h, over 6. Solving for that h is equal to 6 sine of 40. Okay, so now I know my base. You gotta remember, that is a number. I do know my height. We are now plugging it in. So area is equal to 3 times 6 sine of 40 divided by 2. Okay, now when I multiply these things, I just multiply the numbers out front. Be 18 sine of 40. And again, I can simplify there as well. 9 sine of 40 would be the area. That's where I'm going to plug it in. Let's check. Oh, we're in radians, so I got to make sure I'm in degrees. 9 sine 40. Area is approximately 5.79, and we're in terms of yards, square yards. Okay, so trig is not going away this unit. Okay, now parallelograms, same exact formula as rectangles. Okay, now again, with parallelograms, you can define what your base is. Okay, so like in this case, if I am going to make 12 my base, I need the perpendicular distance. The 12 and the 12 go together. Okay, where 12 is my base, 12 is my height. Where I could also use 16 as my base, but then 9 is my height. Okay, it has to be the perpendicular distance from whatever you define as your base. Okay, so again, we said base times height. If I go the green, what I highlighted there, base is 12, height is 12. So area is 12 times 12, or 144 square units. But if I was to go the purple, my base is 16, height is 9, so area is equal to 16 times 9, which, guess what? 144. Okay, so again, that emphasizes the fact that you define what your base is. Your height is going to be the perpendicular distance. Okay, and for that, we're going to leave it at that for triangles, rectangles, and what else? Triangles, rectangles, and parallelograms. Okay. Trapezoids is where I want to concentrate a little bit more time. Okay. This unit, the big thing is you need to know your formulas. We're going to give you the formulas in the end, okay? But we will have a formula quiz where you're going to have to match up the formulas with the names of the shapes. Come test time, we will give you the formulas, but you got to be able to identify the shapes. Okay, so we've done trapezoids, one pair of parallel sides. Okay, those parallel sides are what we consider our bases. Okay, so you notice B1, B2, and the height is the perpendicular distance between your bases. Okay, and here is our formula. Again, you're not going to have to memorize it. You're going to have to know that that is the formula for a trapezoid, but don't have to memorize it. Now, that is saying 1/2 times the height times the sum of base 1 and base 2. The other way you can think about it is height times the sum of base 1 and base 2 divided by 2. Dividing by 2 and multiplying by 1/2 are the same exact thing. Okay, so that's the formula we're going to be using for trapezoids. And let's go ahead, let's give one a try then. So again, hopefully you noticed in the last one The biggest thing when it comes to this unit, identify the shape, okay? So you gotta identify that this is a trapezoid. All right, it is a trapezoid. My formula is this, okay? And then in every single formula, there's unknowns, okay? We're trying to find the area. So I need to know the height. I need to know base 1. I need to know base 2, okay? So then those are the 3 things I need to identify. And if I identify those, it's just plugging it in, okay? Every single year, I see people not write this stuff down and they don't plug things in correctly, okay? Get in the habit. Write the formula. Write down what I need to know. Fill it in, okay? So like in this situation, okay, the 10 and the 14, those are the parallel sides. So those are my bases, okay? So then the perpendicular distance between the bases, that's 12.8. So that is my height. Now I know everything I need to figure out the area. Okay, so just plugging it in, 12.8 times the sum of 10 and 14, all over 2. 12.8 times 24 over 2. Okay, just since, so this is 12.8 times 24, enter, divided by 2. So the area is 153.6 centimeters was our unit, so square centimeters. Area is always in terms of square units. Okay, now when I go here, again, I will just identify what I can. Okay, it is a trapezoid. So again, base or height times base 1 plus base 2 all over 2. Okay, actually, if you take a second, pause, give this one a try. Okay, now that you've paused and tried it, like I'm sure you all have, again, identifying the height, identifying the 2 bases. Okay, parallel sides of the bases, so the 36 and the 24. Oh, I did not put that in the correct spot. Okay, and again, height, distance between those 2, that is 10. Okay, and just plugging it in then, 10 times 36 plus 24, divided by 2. That's going to be 50, 60. So 10 times 60 divided by 2, 300. Okay, I don't need that. So 300, and it's in terms of inches. So square inches is 300 square inches is the area of that trapezoid. Okay, there is an example there. Go ahead, give it a try. You should get 20 units, square units. If not, again, that's the type of questions I expect to hear from you guys when I get back. Okay, now, here, this one I'm giving you a little bit less information. We still need to find those. If I'm telling you find the area, we still need to find base 1, base 2, and the height, okay? What you're going to notice, okay, is the height's not given in this situation, okay? But no, we're not going to move away from what we've been doing. Identify that it's a trapezoid, or if I tell you it's a trapezoid, we need to know, all right, area is equal to height times base 1 plus base 2 over 2. Height, this is a situation where I do not know the height, okay? But I do know base 1, 12, base 2, 30. You can flip-flop them. It does not matter. But the important thing here is I do not know the height, okay? Now, height we always said was the perpendicular distance, okay? So perpendicular distance, if it's perpendicular, guess what I have just formed by drawing that altitude? Right triangle. Guess what unit we had just completed? Trig, okay? So what I'm going to do is I'm going to just draw that triangle out separately. And I know I have a right triangle with this 42-degree angle. I need to find this height. Okay, and the other tricky part about this, okay, is, okay, this is 12. Okay, because I need to know a side length. Okay, and we got a rectangle in the middle there because it's a isosceles trapezoid that we've talked about a while back now, but these little chunks here are going to be split up equally. Okay, so 30 minus 12 is going to give me 18. Divide that by 2. There's 9. There's 9. Okay, so now on this right triangle, I know the angle, I know a side, so I can find a missing side. Now, again, I'm going to use my trig to do that. Let's see. So I got opposite and adjacent to my angle. So tangent of 42 is equal to h over 9. Multiply by 9. There's my height, 9. Tangent of 42. And that's what we're going to use for my height. Okay, so now this is the point where we're going to plug it in. Plug that into h, b1, b2, and we're just going to evaluate. So area is equal to 9 tangent of 42. That whole thing, okay, that's one number, times 12 plus 30, all over 2, okay. Now, you can type it into the calculator at this point, but I don't think a lot of us are going to be very good at this. So let's do a little bit of simplifying. So 9 tangent of 42. Now you got to remember, the 42 is the degree. That's your angle measure. You do not mess with that. Okay, we're multiplying that by 42. Okay, and if I'm going to multiply that, I'm multiplying the 9 and the 42. Okay, so let's even do that. 9 times 42, just to look how we simplify these. That's 378. Okay, so we got 378 tangent of 42, because again, the 42 is an angle. You do not mess with that. Divided by 2. Now I could even simplify here if I wanted to. So 378 divided by 2, 189. Tangent of 42. Okay, so I can type that in. And I'll get approximately 170.18. Okay, and we are in terms of feet. So square feet for area. Again, not necessary to get to this point. You can type it in right here. Okay, 9 tangent 42. Make sure to close that off. Times it by 42. And if I were you, I would hit enter. There's my numerator. Then divide by 2. Either way, you're going to get to that. Okay. A little bit more difficult one there. Now, let's look at a situation of... Okay, we're not going to worry about that. I give you the actual area, okay? Now, we're still not going to go away from what we've just done. This may be a little bit more difficult, but you identify it as a trapezoid, okay? I have a trapezoid. I'm using that formula. But now in this situation, I know the area. Area is equal to 397.8. Okay? Base 1, base 2. Base 1 is 45. Base 2, 16.2. Height, that is the part I don't know. Okay? Now, the other thing too, this is a great example. There's sometimes we will be giving you stuff that is nothing to do with you actually finding what we're asking, okay? So make sure you understand the different parts to the formula, okay? Now, here, doing exactly what we were doing. We are still just substituting into what we know, okay? H, we're just going to leave as H. That's my goal, is I want to find H, Okay, so 397.8 equals height times that 45 plus 16.2 all over 2. Now, this is where it's different. Okay, I gotta find h. Okay, and what I'm gonna do to find h, I see divide by 2. To get rid of that divide by 2, I'm gonna multiply both sides by 2. Okay, that will give me 795.6. Okay, and I'm going to combine here. That's going to give me 61.2. Okay, and times h. Okay, so I'm going to divide by that 61.2 now. And that's going to give me 13. Okay, so again, don't make it more difficult than it is. Yes, it is, like, the process of solving is more difficult, but their setup is very similar. You identify that it's a trapezoid. Write down the trapezoid formula. Identify the different things you know. Okay, we know the area this time, so I'm actually going to plug something into the A instead of the H. Okay, I know base 1, I know base 2, still a substitute. And again, the solving of this, that's what's going to be more difficult. Okay, so I need you guys to go ahead and try the next one, and this one is going to be for base 2. Okay, so now on this one, I will actually go through it quick. Again, trapezoid formula, h times base 1 plus base 2 over 2. Okay, I know the area is 351. I know the height is 20. I know one of the bases, and I need to find the second base. Okay, so again, plugging in those values. And base 2, we're just going to leave as base 2. So in this situation, 351 equals 20 times 9 plus base 2 divided by 2. Again, we're going to multiply by 2 so I can get rid of that. That's going to leave me with, we can do it this way too. So 351 times 2 gets me 702. 20 times 9 plus B2. Okay. There's a couple of different routes you could go with this. I could divide by 20 right now. We could distribute, which that's what we're going to do. That's going to be 180 plus 20 B2 minus in the 180. Okay, so we get 522 equals 20 B2 dividing by that 20. And that's what's going to give us that 26.1. Okay. So again, identify the shape, write down the formula, identify what you know, find what it's asking for. Okay, last two real quick. Again, if I'm finding the area, identify it's a trapezoid. Now, here in this situation, okay, I know this is 6, and when I drop those altitudes, it becomes a rectangle. Okay, so here, that part right here is 6, okay, which I don't know the height. I know one of the bases is 6. I know the second base, 6, 2, 2. That's going to give me 10. Okay, now, in these situations, like I said earlier, we use our trig. But now, hopefully you notice, 30, 60, 90. If that is the situation, you need to use a special right triangle. So those are not going away. Okay, opposite at 30 is the n. Okay, I'm just concerned with finding the height here. Okay, so opposite of 60, that's the n root 3. So in this situation, the height is 2 root 3. Okay, and again, at this point, then we plug it in. 2 square root 3 times that 6 plus 10 over 2. 2 root 3 times 16 over 2, 32 square root 3 over 2, which would give us 16 square root of 3. Again, those are things you got to be able to do. Okay, I can't take extra time. You got to be able to do operations with radicals. Okay, so that would be my area. Oh, and let's go ahead, we'll do square units. Okay, so like when I go here, okay, that's 8. Okay, and I need to figure out that side. Okay, 45, 45, 90, and, so that's 4, making that 4 as well. Okay, so in this situation, I'm not going to finish it off, but your height would be 4, base 1 would be 8, base 2 would be 16. Plug it in and get your area. So, big emphasis on those two. Your special right triangles, your trig, all that stuff is not going to go away. You're going to have to use that stuff to find specific measurements within these polygons that we're doing. And it's not going to be just for these ones. So, if you struggle with last unit, make sure to touch up on it, and let's get that cleared up. All right, homework for this day 1, unit 9, day 1 homework. If you are going to be on OneNote, I did not do this on OneNote. This page, the area of triangles, rectangles, and parallelograms, these 2 pages are completely optional. Okay, but I am going to check this page, and the first 2 pages. Okay, so the ones that look like from this CUDA software worksheet, those are not required to do, but those are things I will expect you to be able to do. Okay, it's triangles, rectangles, and parallelograms. So those are the basic ones. You need to be able to do them, but not required for the homework. So again, if you got questions, make sure to bring it up the following day, the next day I see you guys, and we'll get things cleared up. Have a good one.